Hello, friends. Um, One of my emails is a Google search of Pluto. So here's this great picture of Pluto that they've put together, and the basis of this article is how come there's no great pictures of Pluto's far side. So I go down and down. Well, I'm not going down yet, but I go down, down and down, right? Here's some nice graphs. They can't blow them up. Oh well. So we keep going. Here you go, far side. Some kind of strange pictures. Cool. Oh, the fusion enabled Pluto orbiter and lander was a 2017 proposal funded by NASA that suggested a direct fusion drive could send 1,000 kilograms or 2,200 pounds orbiter to Pluto in only 4 years of travel time. Did you know that NASA was working on a direct fusion drive? I mean, well, theoretical. This is a paper study. This is a paper study. So let's open this up. A top Here it is, the Thomas Fusion enabled Pluto orbiter and lander final report. And this is based on the Princeton field reverse configuration fusion reactor under development at the Princeton Plasma Physics Laboratory. A direct fusion drive from PFRC. Did you ever hear of PFRC? I never heard of PFRC. So, let's see PFRC. PFRC. Princeton reversed field configuration. Well, look at that. Right here in Wikipedia. One rotating magnetic field pulse of the PFRC-II device during an experiment. Oh, wow. One rotating magnetic field pulse of the PFRC device during an experiment in slow motion. Did you know about such a thing? I did not know about such a thing. Wow. Let's see if there's any good pictures about what this reverse field configuration is. No, here it is. I guess this is the closest we're going to get to understanding. So cool plasma, energy absorbed, ion acceleration. So the cool plasma comes into here. The fusion happens. And that fusion happens, and the product of that fusion leaves out here as accelerated ions. Yeah, I mean, in theory, it sounds beautiful, but I can see. I mean, we both know the engineering. The engineering of some of this would have to be amazing, especially right here at the nozzle coil. Although not impossible, but I mean, supposedly fusion happens. Some energy is absorbed for internal energy. So that's cool. But still, I mean, the well, let me see what does it say? Shown on the left and the DFD on the right. So, cool plasma flows around the fusion region, absorbs energy from the fusion product, and then it's accelerated by a magnetic nozzle. Okay. So the fusion happening in here is not related at all to this plasma. This plasma is circulating around this fusion, and yeah, so it's cool plasma flows around the fusion region, absorbs energy from the fusion products, and then is accelerated by a magnetic nozzle. Okay, that magnetic nozzle would have to be incredibly powerful, but I mean, with some research, it's doable, right? So, can I download the full text PDF? Download. Oh, okay. So can I save it? Is it downloaded? No, I don't want to print it. I want to save it. Well, I don't know if it's been saved or not. But okay, so there's the idea. Continue with Google. Coming still with me? Let's see where this goes. Sure. I'm not a researcher. I'm just interested in reading and discovering research. Well, they lost. I thought it was going to save it. PFRC, right? Can I download the citation? Plain text. Yeah, okay. Save there. Okay, that was a long process, wasn't it? I'm sorry. But let's just want to see where this rabbit hole goes. All right. Well, this is obviously a long, complicated rabbit hole. But PFRC-II, direct fusion drive. My goodness. All right.